All right, for our notes today, we are going to work through three sections. We're going to first work through the product rule, then the quotient rule, and finally the power rule. And I'm going to hopefully have you guys kind of arrive at these rules yourself by working through the expanded form that we worked with yesterday. So here's how this is going to work. We're going to do example 1 as a class, and we're going to expand it out and simplify it. Then I'm going to ask you to make a prediction about what that rule is. And finally, we'll formally define this rule together as a class. Then we'll practice applying that rule or shortcut in example 2. And we'll move on to the quotient rule and kind of repeat that same process. So if we go to our slide deck here, we have example 1 right here, which we're going to kind of work through the same steps as we did yesterday, rewrite in expanded form, and then simplify. So go ahead and pause your screen, try this on your own. When you're done, unpause and check my work. So in this case, we have w to the 4th. We can write that out as w times itself 4 times. Then we also have w squared, which will multiply itself twice. And if we condense that back down into one final solution, it looks like I have 1, 2, 3, 4, 5, 6 w's total. That's going to be w to the 6th power. So now I want you to take this and make a prediction on your note sheet. What is the shortcut that we can use for this problem type? So take a couple seconds, jot down your prediction, and then we'll define that form or rule in a second here. So some of you probably noticed that we were just simply able to add these exponents up. And this is our product rule. So let's make sure we get our product rule jotted down on the right side of our sheet, kind of formalizing this. But if we are multiplying terms with exponents and they have the same base, we can simply add those exponents together. Let's kind of see how that works out in this case. If we have w to the 4th plus w to the 2, we can write that as w to the 4 plus 2, which is equal to w to the 6th power. So let's try that on example 2 here. X to the 3rd times x to the 8th power. Try to apply that rule. No need to go in an expanded form. We can use our shortcut here. Try it for yourself. Pause it, unpause when you're ready. In this case, we'll have the same base. So we have x, and our exponent will be an addition problem of those two. So our exponent will be 3 plus 8. And in this case, we'll get x to the 11th power. You certainly could have solved this by writing it out 11 times and recondensing it. But this shortcut, this product rule, does kind of help us go through this quicker. All right, now we're going to kind of repeat this process, but for our quotient rule. So let's try example 3 on our own. Rewrite in expanded form first, then simplify. Go ahead and pause your screen, unpause when you're ready. So if I'm rewriting this, I have, it looks like a to the 6 up top. So I have 6 a's multiplied together, 4, 5, 6. And on bottom, I have a to the 3rd, so a times a times a. Then to simplify out, we can cross off any pairs that show up on top and bottom. So looks like we have 1 pair, 2 pair, 3 pair, and I'm just left with a to the 3rd power up top. So just like we did before, go ahead and jot down a prediction on your note sheet. What is the shortcut that can be used for this problem type here? So this rule or shortcut is going to be called the quotient rule. And just like the previous one, we were adding our exponents together. If we're dividing terms with similar bases and exponents, we can actually subtract the exponents, and it's top minus bottom. So let's write this rule down onto our sheet, and I'll kind of quickly show how this comes into play. In this example, we had a to the 6 divided by a to the 3rd. So we could rewrite that as a to the 6 minus 3 if we wanted to, which is just equal to a to the 3rd power. All right, let's try applying this quotient rule now by ourselves. So we have x to the 5th divided by x to the 2nd. So go ahead and pause this, try to apply it yourself if you can. In this case, we have x to the 5 minus 2 if we're applying that quotient rule, and that'll give us x to the 3rd power as our final answer. Again, we can absolutely expand this out if we wanted to and find that easier. This just provides a little shortcut for us. Okay, our last rule here that we're working towards is called our power rule. So let's start by trying this out, exploring with example 5. We have x to the third, and that is raised to the second power. So let's pause our screen, try this for ourselves, expand it out all the way. I'm going to show this in 2 steps here. So we have x to the third, and this whole thing is multiplied by itself twice. So we got x to the third times x to the third. And if I wanted to expand that out some more, then let's rewrite it. I'd have x times x times x times x times x times x. And that whole thing could be recondensed down into x to the 6th power. So go ahead, make a prediction. What is the shortcut that can be used for this type of problem? Pause the screen, jot this down, and unpause it so you can come back to the actual rule. All right, so this exponent rule is called the power rule. And when we have, when we're taking the exponent of something that already has the exponent and we're surrounded by parentheses, we're going to multiply those exponents together. You see that 3 times 2 gave us 6 there for our total exponent. Same thing's going to play out with this power rule. So jot that down. While you're doing that, I'll kind of show through how this works in our shortcut form. So instead of expanding it all out, we could have rewritten this as x to the third power times 2, and that would simplify as x to the 6th power. All right, so this very last example, try on your own. It's the power rule here, so y to the 4th, and all of that is raised to the 3rd. Pause your screen, try it, unpause when you're ready. In this case, we have y that we can rewrite as 4 times 3 as our exponent, and that gives us a final term of y to the 12th power.